Hello, I'm Juan Camilo, and today we are going to see how to implement Kmeans in R. The first thing that we're going to do is to open a script. It's already open here, and we are going to put the name Kmeans. The data that we're going to use for this exercise is going to be arroz secano Nicaragua, rice in Nicaragua. And in agriculture, it's very common to see how is the behavior, the yield regarding the soil variables, like for example, pH. So in this case, we are going to see how it's the behavior of the soil. We're going to choose these two variables, yield and pH. So it's important to mention that in order to choose two different columns or two variables, we first put the data frame that we are going to have as a base, and then in parentheses, and the columns that we're going to choose. In this case, it's data, comma, and the columns that we are going to use. And let's see how the data looks like with head. So here we can see the yield and the pH. And we're also going to locate a scale or standardize the data to avoid further problems. So we're going to use the scale function that we've used before. And let's see how the data frame looks like. So once again, head. And this data is already standardized. Now let's plot in a graph to see what's the behavior of these variables. So with the plot function, remember that in R there are multiple functions. Plot is the basic function that's in R by default, but there are different libraries available. Oh, and we're going to use another one to graph the groups. So in the first position, we are going to write a yield to include the yield, and then the second one, the pH. The title of each one of the sides of the graph, the title, and let's plot the graph. In the lower right part, you can see the distribution of these two variables. In the beginning, it's very hard to know how many groups there are. And this is one of the challenges that we have when we are doing clustering. It's hard to identify the amount of groups. So right now we're going to see how K-means works if, for example, we choose 4 different groups. So there's a function available in R that's called K-means. Here it is, K-means. And in order to know what are the parameters, we're going to write K-means. And this shows us that we have the X centers, which is the data frame or the matrix in our case. The center would be the amount of groups that we suppose exist. The maximum number of iterations. Remember, the K-means is an algorithm where we establish how many times it's going to be done as a parameter. In end start, as I mentioned during the presentation, K-means is a non-deterministic model. So in other words, the centroids are located randomly in the beginning. With end start, we choose how many times we are going to choose the centers randomly. And these are additional parameters that we're not going to use during this video, but I would like to invite you to go over them and read them. So now with Kmeans, we are going to execute this line. And we're going to say what it tells us. So it tells us that there are 4 clusters. Sizes are 38, 89, 88, and 72. This is the location of the centroid for each one of them. The clustering vector. This tells us where the data belongs to. The addition of the squares by cluster. Now we're going to plot. And these are the additional components when I use Kmeans. Very well, so now we are going to plot these groups. And the lower right part, you'll see how these 4 groups are grouped, each one with a different color. So it's important to mention that we can see that there's a partition in every group can be differentiated, and that inside the group you find compacted information. However, this is a visual aid and it probably isn't so accurate. So as I mentioned in the last video, we are going to use the show the elbow graph to determine the amount of clusters. So for this, we're going to create a small function in R. That we're going to use that we're going to name the elbow rule, regla de codo. And remember that in R, when I want to use a function, I put the word function and then return. So this function shows us the amount of groups that I want. Then it does the clustering by that amount of groups. And from this one, I'm going to extract the sum of the square in order to plot our elbow graph. So we run this. And now we're going to create the plot. So the first step is to establish how many maximum groups there are. So let's say 20 groups so that the graph is easy to read. And the Shapley function is to apply from 2 to the maximum in this argument. I will say the maximum was 20. So this means that this function that you have here is going to take the argument from 2, 3, 4, 5, and it's going to save it here. So the result is going to be a vector with a size of 18. And then we're going to create the data frame called elbow. So let's run these 3 lines. No errors here. And finally, we're going to plot the elbow. So in the elbow plot, we see that we have to choose the point where the descent begins. Not in the convergence, because if it were so, we'd had many points. So it has to be the inflection point where you start to see that the graph descends. So according to this plot, I would propose that the number should be 10. And remember that in the beginning we put 4, and that's the number of groups that were homogeneous. But with this graph, it tells us that it's 10 groups instead. So let's plot it once again. Let's plot these two lines. And let's change this 4 to a 10. And now we're going to put here 10 also, so don't we get confused. And let's plot it here. So let's put 10 here once again. And let's run it. So these are the 10 groups now. And we can see that these look a little bit more compact. If we see this one, the blue one, if we probably do another cluster separation in this one, it's going to create some more. These probably are too far away. But on the other hand, we have this one, this purple one, that's a lot more compact, where all the points are closer together. So I think that this one's going to be left like this. This is a fixed cluster. And another cluster that I think it's fixed is this one, the pink one. So we already started to detect those clusters. And remember that being able to determine the amount of clusters, it's work that's not only statistical, but it's also related to the zone of study and how they behave. So it's good to validate all these results with a person that's in charge. So in this case, it would be good to highlight this data and to talk with an agronomist or someone that understands how this works. That's all for today. Greetings.